1.6 vector addition and subtraction. So for addition, we simply add the tail to the head. What does that mean? I'll explain to that a little bit later. So you can just start at the head. How many x and y values you can go translate on the left, right, up and down, depending on the size of the vector. So let's come over here and let's use some simple logic and some simple math. So if you've passed trigonometry, you should be able to do this. So let's draw a vector. And I'm going to make it quite simple, and we'll draw a vector right here. And let's say this is 10 length, and we have an arrow to denote the direction. I would probably say this is something around like 30 to 45 degrees, but obviously we can't put a number on it without proofs, so I'm not going to. We're just going to say that this is 10, heading in what looks like the northeast direction, which it is the northeast direction. So let's say we have another vector, and we'll say we'll place it down here. And we'll say we have 2. Well, how do we calculate this? So let's assume that we have -3 here. This is -3 on the coordinate plane. This isn't drawn to scale, obviously, because this 10 is about 2 times bigger than this arrow, and it's 5 times bigger in value. So let's say we have -3, and let's say that the top of this arrow is going to be -2.5. So that means we have 2.5 here. 2. I'm not going to solve for the third side. Instead, I'm just going to use the Pythagorean theorem. Wait a second. Sorry, it should be 0.5. Realize that now when doing the Pythagorean theorem. It can't be bigger than the hypotenuse. Some pretty simple logic there. So we'll do b squared. Subtract 0.25 there. So it's going to be 3.75. Square root that. And that'll be the x direction, the y direction. So here, at the top, very top here, we can take this coordinate because we'll be given the x and y's. And that's how I calculated this vector length here. So we'll do 0, and let's say that this is somewhere, this is at height of 5. So that means this is 5, and to solve the other one, we'll do 10 squared equals 5 squared plus c squared, or b squared actually, because c squared is the hypotenuse. Subtract 5. That's going to be 75, so it's going to be square root 75, this length here. So now we know that since this starts at the origin, this coordinate point will be square root 75, 5. And then we'll add this vector on top, which, as we know, it's square root 3.75. So we'll just add square root 3.75 in this net direction, and to do so, you just add the, sorry. Let me move this to the right, actually, because it's kind of clogging up everything. Then we'll add something that's 3.75, and 0.5, which will give us like a square root 2 vector. Technically, since we calculate the hypotenuses, no, sorry, that's not how it works, because if you have like a vector like this way and then you connect to a vector this way, you actually calculate the hypotenuse of the resultant vector, and to do so, you just add these two together and make a new right triangle in which you can apply the Pythagorean theorem and find that out. So that was basic vector addition and subtraction. For vector addition, all you do is subtract the points. So I'll give you an example right here. For addition, you just add tail to the head, and for subtraction, you can simply just take it away. So if it's like this, we subtract in the opposite direction. So that's the logic there. And subtraction and addition are basically the same thing, except that subtraction will usually have the vector going in the opposite direction. So that's the logic behind that, and that's physics 1.5 and 1.6. Pretty logical, pretty easy. The nature of physics, everything. So, yeah.